Hi everyone, and nice to see you now in the fourth season of Spatial Warsaw Seminar. So we have today a very special talk of the freshly baked PhD student on our faculty, Monika, whom I welcome in now. As you know, the rules: talk first and then the questions. So, floor is yours, Monika, and good luck.
Hello everyone. Today I'd like to present my research, which is actually the results from my master thesis. And the title of that research is Spatial Diversity Innovation, Mapping High-Tech Firm Dynamics. So what drove the idea for this research was basically the thought that when we think about big innovations and how they occur nowadays, would they still be expected to occur within the firms in the city center, or maybe they can appear actually in the suburban areas, peripheral areas, as we see the change in the access to the computers, how people work nowadays. We can track where the firms are located, and we can try to determine what factors actually help those firms thrive or struggle in the different environments. So as for the motivation for research, we know a lot about the economic importance of the innovation-driven firms. So here I'm considering mostly the technological firms, which bring out the so-said innovation into the markets, and many economic models underline the importance of technology and technological firms that drive those innovations. As even in this year's Nobel Prize, we had the concept of the creative destruction and the changes that these new technological innovations bring to the economy and how they help the economies grow. But as the technological firms have the important part in this, they also are very prone to exiting. So they often have a hard spot when it comes to maintaining their presence in the markets, as we see that we constantly have new innovations, new products, for new systems appearing. So there is a big competition in the market, and it might be helpful to determine what aspects might help those firms survive. So we know a lot about the factors that might actually help firms survive, and I'm talking about normal firms, technological firms, so any kind. And we know that they are not only limited to internal factors like human capital, like financial capital, but we are talking also about the location of the firm. So the environment that they are in can very greatly determine how they might perform. And here I'm considering both the wider context, so whether the firm is located in the city center, in suburban areas, in the peripheral areas, so the core periphery pattern, and also I'm considering the more local changes. So in which neighborhood the firms are located in, specifically what are the neighbors of those firms. So we see a growth in the number of so-said microgeography studies, where we use the very defined locations like points or data gathered at the grid level that can help us determine how does the very, very close environment of those firms look like. And this is important as we know a lot about the agglomeration externalities that might arise. We are thinking here either Marshallian or Jacobian externalities, so those that might arise when we see similar firms clustering together, and then also more diverse one, and that can help bring the knowledge spillovers. So generally, that was the idea for this project. So I wanted to look at the determinants of the firm survival of technological firms, and specifically look at the location patterns. So I posed a research question, which was, how does the immediate local environment of technology-based firms influence their survival? And how are these effects shaped by the wider urban-rural context? So first, when I'm talking about the local environment, I mean the very local, the neighborhood level structure of the firm. So what type of firms are located next to us? Whether are those firms with the same specialization? Do they pursue the same activities? Are they maybe somehow connected? So we are talking technological firms, but different specializations, or are we talking completely different firms, like those related to, we have technological firms, but they are mostly located within firms related to different specializations. And then the wider rural context, which is related to the core periphery. So based on this and the review of the literature, I proposed 4 hypotheses. First one was that the increase in the number of the same specialization firms for the technological firms would lower their chance of survival because of the high competition at the very local scale might result in the crowding. And then this crowding and this competition might outweigh the potential spillovers that might arise when we are located within the close proximity of firms similar to us. Second hypothesis was about that when we see an increase in the different technological firms located next to us, so not with the same specialization, but also working in the broader domain, we see the growth in the survival rate. So we observe higher chance that the firm survives on the market. And this is related to the concept of related variety. So we have different firms, but they are somehow still related to each other. And there are some complementarities arise. So those firms can exchange knowledge and in fact, maybe come up with more interesting concepts and their products. Then the fourth hypothesis was about that when we see an increase in more non-technological firms, so we're talking generally the more rich structures of the firms in our close proximity, we will see a higher chance of survival. And then the 4 hypotheses is related to the broader urban-rural context. So as I reviewed the literature and I came up to a few papers that were also mentioning that when we look at different regions and we compare the growth of the given regions and how we have different locations of them. So we see that actually those mid-density areas, so neither city center, neither rural areas, might have the best, the most favorable conditions because they offer the condition when we have still good access. We are close enough to the city center. We have close enough access to the workforce, but we are not met with the high prices, the high congestion that the city centers bring. So the hypothesis, I thought that also the survival would be the best in those mid-density areas, not necessarily the core of the cities. So when it comes to the analysis and how I wanted to actually verify those hypotheses, I used the data from the official register of enterprises in short REGON, which encompasses all of the firms registered and that are actually functioning in Poland. I used the data set for 2 years, so 2012 and 2021 for the Mazovian Voivodeship in Poland. So I believe that this area is great for this type of analysis because we have a wide variety of the places. So we have one big city, the biggest in Poland, Warsaw. Then we have some mid-sized cities like Płock, Radom. And then we have also rural areas, suburban areas. So we have the whole context, I would say, the whole spectrum that could be analyzed. And within all of the registered firms, as far as I remember, for 2012, that was around 900,000 firms, around close to a million. And for 2021, we had over 1 million firms in total. And from those years, we look closely at the technological firms. So they are the main point of interest. So we are analyzing the things that might affect the technological firms' survival. So what we had in the initial data set, we have the unique REGON code, so the specific identification for each firm that can help us track that firm over the years and compare within different registers. We have the economic sector. So first is the broader category. We have 21 sectors like agriculture, construction, financial services, and so broad types. And within those sectors, we can also distinguish a different type of activity. So for example, when we're talking about some, I don't know, agriculture, we can say what specific type of activity it is. So is it connected maybe to animals, to some wheat, whatever, right? So and it's the same for the technological firms. And then we have the size of the enterprises measured by the number of employees. So we don't have the specific number of employees, but we have some 5 broader groups. So micro firms that will be under 10 employees, then from 10 to 50, 50 to 150, etc. So we know the broad classification when it comes to size. And what's important for this analysis, we have the specific address and the geographical coordinates of each firm. And this specifically can help us determine where is it located and what are the neighbors of the firms. So for the analysis, I wanted to check what can affect the survival. So first thing that had to be done was classifying actually the survivors and the exits, as I call them, in the analysis. So what I did was take the 2 registers from 2012 and 2021, and I tracked which of the technological firms in the register in 2012 survived until 2021. So we had 2 options. First, if the firm survived and was in both registered, so 2012 and 2021, then it was marked as 1. And then second situation, when the technological firm was present 2012, but didn't survive until 2021, then it was marked as 0. This is the variable that was later modeled. It is, of course, important to mention that when we usually want to help find the determinants of survival, the better variable would be the time, for example, so we would like to have the exact entry and exit dates of the firm. We didn't have that, so this is what we work with. So we have the survivorship status. The next variables were connected to the local neighborhood changes. So what I did in the analysis, I measured the differences in the neighborhood, what they specifically do. So for each firm, we know its exact location and we know its exact specialization. For each of those firms in 2012, it was around 40, I believe 42,000 of them. And around each firm, I created a buffer, so 500-meter radius, where I could see what firms were the direct neighbors of the focal firm, the firm of interest. And I calculated what is the number of technology-based firms with the same specialization. So here would be the so with this, I could check the similarities when it comes to the Marshallian externalities, right? So the similar firms located next to us. Second was the calculation of the number of technology-based firms with different specializations. So I wanted to see what is the number. So besides those firms with the same specializations as us, I wanted to see what are the different technological firms. Then I calculated the number of non-technology-based firms, so all other neighbors. And then based on not specialization but broader sectors, I calculated tertiary Hirsch index, which could tell us about the specialization level of the area around us. So whether there are just a few sectors that concentrate here, or do we hold the full, for example, the full spectrum, all 21 firms are there, and we could compare the shares. And then I calculate the location quotient that can help us compare the structure of this neighborhood to the base level, which is the whole Mazovian region. And for each of these variables, I calculated them for 2012. And then the same thing was done for 2021. And this allowed us to measure the changes between those 2 years. And what's important is, as for 2012, it's nothing extra. We just measured for the firms that survived. We measured 2012, 2021, and we compare. But something different had to be done for the firms that didn't survive up until 2021. So I calculated those measures for year 2012, and then took the exact coordinates of those firms to the data set in 2021 and looked what would the neighborhood look like if the firm was still there. So with those changes, I wanted to see if the differences in the structure, if some market dynamics could have maybe might have made the firm exit the market. So this is kind of like counterfactual analysis where we see what would have happened if the firm was still there. So what is the structure? Then I came to the settlement classification dummies. So like I said previously, I wanted to look at the core periphery pattern, and I wanted to classify in which kind of environment given firm is. So for this, I use the Gurba classification, the degree of urbanization, which is the classification proposed by the Joint Research Center next to the European Commission, and one of the main researchers who developed this was Louis Dijkstra. And what the degree of urbanization uses the population grid data. So it is based on the 1 by 1 kilometer squares, in which we have the population number. And by clustering, first as knowing how many people are located within each of those grids, and then clustering those grids and seeing what are the counts in them, we can determine what is the classification for those grids. So for example, here we have the Mazovian region. We have a snapshot at Warsaw, where we have 601 grids. And for each of them, we have first the number of people in the grid. So we can look at this table. So it's here some thresholds that we have. And then we cluster those grids by some more specific thresholds. And then we can determine whether the given grid is urban center, so the most densely populated area, where in each grid we have at least 1,500 inhabitants, and then those clusters form at least have at least 50,000 people in them. Then we have the mid-density areas. Within those, we have the dense urban clusters, semi-dense urban clusters, and suburban or peri-urban grid cells. And then we have the more peripheral areas, which are divided into rural clusters, low-density rural grid cells, and very low-density rural grid cells. I perform this classification for the Mazovian region directly from this population counts for the grids. And this here map on the right is the result of that classification. So for each of the grids, we know what is the level of urbanization. We see the highest density for, of course, the Warsaw region and some of the outer areas. We see that also for the 3 bigger cities. Then the yellow and brown colors would suggest the mid-density areas, so the some suburban areas and peri-urban. And then the colors of green suggest the rural areas. The darker, these are the more dense, and the lightest colors suggest the lowest possible density, of course, when we're talking about this classification. And then for each of the analyzed firms in the dataset, I could connect those points with the grids and the classifications, and I could determine for each firm what is the settlement type of the firm that it actually operates in, right? Then the other more technical things was measuring the accessibility to different markets. So besides only having the the category of the grid, I calculated the minimal distance to cities of different sizes. So we have minimal distance to a core city. We have only one of those, Warsaw. Minimal distance to mid-sized cities, then regional cities, local big cities, and local small cities. Each of them is determined by the number of inhabitants. And with this, I wanted to additionally catch the accessibility to urban centers with different sizes, when we would know what is the possibility, for example, of attracting some labor, right? So people who would work in those companies. And then technically, I wanted to add also the dummies for the size of the firm, the technological intensity, because I had the division of the medium high-tech, and high technology intensive firms. And then I also marked the 5 dummies for the most popular type of activities within those technological firms. And when it comes to finally the modeling, as I said, I measured the survival as the binary outcome. So 1 was for the firms which were present in both data sets, and 0 if the firm exited after 2012. So I had 40,000 observations that were put into the model. And first I used the logit model, in which I could actually verify the proposed hypothesis and look at the relations between those variables and the so-set survival. And then I explored machine learning models and some explainable AI tools that could showcase maybe some potential non-linearities, and just looking at how these models perform next to each other. So the logit model and then those machine learning models. And this below is the structure that I used for modeling. So I have the modeled the dependent variable, which is the survival, either 0 or 1. And then we have variables connected to the local neighborhood. We have some dummies, so whether firm is a micro firm, small, medium firm. We have the type of activity, medium, high-tech, high technology services. We have some dummies for the most popular technological firms groups. Those dummies relate to the classification, the Gruba classification, and distances to different city sizes in kilometers. And for the main results for logit, so basically most, I believe, 2 out of 3 variables from the distance to the cities were not significant. All other variables were significant in the model. And the main results were that first, more technological firms within the neighborhood, so more technological firms with the same specialization in the neighborhood made the survival rates lower, which confirmed the first hypothesis. Then the more different technological firms, so the, I would say, related variety idea also showed that the survival rates are lower, which in fact made me reject the second proposed hypothesis. And then more non-technological firms in the close proximity made the survival, the possibility of survival higher. Then when it came to the more structural changes based on the sectors, we saw that increase in structural specialization concentration also positively affected survival. And also, which is, I believe, one of the most interesting findings, that it was confirmed that significantly that the best condition for survivals were actually found in the medium density areas, and through usage of those dummies related to the being either an urban center, dense urban cluster, and semi-dense urban areas, we saw the significant and the highest coefficients for those variables. And which is to be expected, micro and small firms were more at risk, so their survival chances were lowest than for the big firms. And secondly, besides the logit modeling, that help answer the questions and look at the relationships between the variables. I also trained two machine learning models, so random forest, which is here, and then XGBoost models. I wanted to compare the prediction between the classic logit models and then those random forest and XGBoost, which is not shown here, but they had higher positive predictions, so they were better at predicting whether the firm would survive or not. But the most important, and what I wanted to show here, is the results from some of the XAI methods I used. First was the permutation-based feature importance, which helps show which variables contribute most to the trained models. How is it done is that we have the trained model, we take each of the variables separately. So for example, first for the random forest, I take the variable local non-tech firms, I shuffle the variables within those, and I look how much the results of the modeling change. The intuition is if the results change highly, so we see big differences, then the variable is important from the model. If the changes are not that big, we see, okay, like this variable is not that important because shuffling the variables didn't change the results that much. And what we see on this plot is actually the comparison of the importance of the variables. And we see that for the machine learning models, so here are the tree-based models, random forest, and XGBoost, we see that the ML models could extract more information from the neighborhood and accessibility measures, which for me was a sign that possibly there might be some nonlinearities when we look at the relation. So the idea is that, for example, when we see small increases in the number of firms with the same specialization, the effect might be, for example, negative, but after some threshold is met, then the situation might change. So this also was the sign for me to, for example, explore accumulated local effects, which can help us explore some nonlinearities in the effects of the specific variables. Here on the plot, we have the example for the variable which measured the number of other technological firms in our neighborhood. And as for the logit model, which is represented by the blue line, we see that the effect is linear, like we would expect it's normal, and it was negative. But when we compare the machine learning models and we look at their effects, we see that for some of the values, so for example, the smaller values, we might observe some positive effects, and after some threshold, the result is different. So this is basically the thing that I did in this work. But based on those results, the idea is also to extend this analysis, and I'm interested in looking at like microscale spillover analysis. That would be somehow a spin-off of the idea proposed by Arzagi and Henderson from 2008. They studied the location, also using point data. They studied the location of the firms from the advertising industry in Manhattan, and they showcased that how we could observe the attenuation of the effects when it comes to the location of those firms. That, for example, when we look at the distance from 0 to 200 meters, we see very high positive effects of presence of similar firms. Then we go a bit further. So, for example, from 250 to 500 meters, the effect is still positive and significant, but the coefficient is smaller. And then we go further, the effect might, for example, become insignificant or be significant and negative. So I wanted to do a similar thing for this paper, and maybe track more specifically the potential nonlinearity. So not only tracking the changes only at the fixed radius of 500 meters, but exploring different distances and looking how this might change the results, and if we can, with, for example, also econometric modeling, explore those non-linearities. So this is it. Thank you a lot, and if you have any questions, I'll be happy to answer them.
Yeah, thank you, Monika. Thank you very much. And now I have to close the so-called Zoom part. So online guys, we were happy to see you, and we hope that you were watching us even in asynchronic mode. So we see each other in 2 or 3 weeks. Stay tuned for Spatial Warsaw Seminar, and bye.